Hey people, and welcome to this video. In this video, we'll be working on the Mathematics Paper 1 for June 2023, and it's specifically from the Gauteng province. This is a grade 12 exam, so you guys can also use this along with the other exam papers that have already been uploaded. I do have some videos on those, okay? So the 2025 and 2024 ones are already up, and you can just use this to help you prepare for your June exams. Okay, looking at the instructions, just remember that, if necessary, round off to 2 decimal places unless stated otherwise. And remember that the diagrams are not necessarily drawn to scale. Okay, so with that being said, let's get into this video. Question 1.1 says given 12x is equal to x squared, 1.1.1 wants us to solve for x. Okay, so 12x is equal to x squared. I know that it can be tempting to try to get rid of this x by dividing both hand sides by x, but don't do that. And the reason why is because you don't know what x is yet. Okay, if x is equal to 0 and you divide it by 0, then your equation is just undefined, okay? So make sure to avoid that. And so what we can do is we could just leave this x squared on this side and transpose the 12x. So we have 0 equals x squared minus 12x. And now you see we have a binomial on the right hand side. You see you have two terms and you need to solve for x. So the only type of factorization we can use here would be highest common factor. So we're going to take out a highest common factor of x, that is what's common. And what are we left with in the first term? We would be left with, say, x squared divided by x, and that's how you'll find out what is left. Okay, so that would give us x. And then second term divided by x. You see how the x's would cancel, and then you have negative 12. Okay, we're not dividing by x. I'm just checking what is left in that term. Okay, now we have a value multiplied by another value, and they give us 0. Okay, the only way that that is possible, and also to ensure that the equation actually is equal to 0, is if x is equal to 0 or x minus 12 is equal to 0. So x is equal to positive 12 if we transpose that. And these are our answers. Moving on to the next question. Question 1.1.2 says, hence or otherwise determine the value or values of p if p squared minus 1 all squared is equal to 12 times p squared minus 1. Okay, leave your answer in third form where necessary. Do you see what they're doing with this? Okay, how this looks a lot like what we had here. You see how we have 12 and then x, right? We have 12 and then p squared minus 1. And then we have x squared here, and then p squared minus 1 all squared. So what we could do to solve for this equation is we could simply say, fine, so let me just rewrite this equation first, okay? And since we can see that they're clearly just replacing this p squared minus 1, okay? We're going to replace that with x because that's actually what is going on, okay? That's x squared, that's p squared minus 1 all squared. So in place of p squared minus 1 all squared, we're going to replace that with x. So we'll just say, let x equal p squared minus 1, okay? And if we do that, we're simplifying this. That means that x squared is equal to 12x. But we know the solution to this equation. X squared equals 12x is the same thing as 12x equals x squared, okay? And we saw how those were equal to, because x is equal to 0 or x is equal to positive 12, right? So in place of x, now we can replace it back with p squared minus 1. So we'll say p squared minus 1 equals 0 or p squared minus 1 equals 12. And all we have to do is solve for p here. Okay, so here you see that we have a case of difference of two squares. You can factorize it like that, or you could just choose to transpose this one. So we have p squared equals 1. And then to find the value of p here, you need to get rid of that squared by square rooting. What you do on one side, you must do on the other side. And this is an equation, so you need to remember the positive and the negative solution. So it means p is equal to positive or negative 1, so negative 1, or p equals positive 1. Or p could be equal to here. We will just transpose that. That's also, we can just use the same method. So p squared is equal to, and that becomes a plus 1 there, so it's 13. And then we can just square root both hand sides. So square root and square root. This is positive and negative. Therefore, p equals negative square root of 13, or p is equal to the positive square root of 13. And these would be our answers. We have 4 answers for this equation. Okay, you could have also written it as p equals positive or negative 1, or p equals positive or negative root 13. And that would be fine. Okay, and that is it for our answer. Moving on to the next question. Question 1.2 says, solve for x if 5x squared plus 7x minus 2 is equal to 0, and you need to round off your answers to 2 decimal places. So this means that we are going to use the quadratic formula. So do you see how our equation 5x squared plus 7x minus 2 equals 0 is already in the standard form of a quadratic equation? Okay, it's in the form of ax squared plus bx plus c equals 0. So we can go ahead and get the quadratic formula to solve for x, and we can substitute. So x is equal to, we can see that b is 7, so this is negative, and we have 7 plus minus the square root of 7 all squared minus 4 times a, which is 5, and c, which is negative 2, all over 2a. So that is 2 times 5. Okay, and let's go ahead and get our answers. Okay, so you can see that the first solution for x we get with the positive is 0. And that will round off to 24. So 0.24, or, and then if we change this sign to a negative, so now we change that to a minus, and we get negative 1 point, and that will also just round off to 64, as we can see over there. So negative 1.64. And those are our answers. Moving on to the next question. Question 1.3 says, solve for x if the square root of x plus 6 is equal to x. Okay, so the square root of x plus 6 equals x, and this is for 5 marks. Interesting. Though the reason I'm saying it's interesting is because normally, if they've already isolated a surd for you, they usually don't give you an extra mark. But you know now you're definitely supposed to check whether your solutions are valid at the end of the day. Okay, so they have isolated it for you. The surd is on its own, and that is great. And now we can get rid of the surd to solve for x. So we're going to square both hand sides. That's what's going to get rid of a square root. And when we do that, this breaks open, and now we have x plus 6 is equal to x squared. And now you can see that this is a trinomial. So we can transpose everything here over to the right hand side. And so we have 0 equals x squared minus x minus 6. Now factorize. So we open 2 brackets, and then we have x multiplied by x gives us x squared. And then we need factors of negative 6. So factors of negative 6 that can help to give a negative 1 in the middle. So we can think of factors like 3 and 2. Okay, 3 times 2 is 6. But this is negative 6. So one of it needs to be negative, which should be negative so that the middle stays negative. You should give the negative to the bigger factor, okay, the larger factor. So this is negative 3 and this is positive 2, because negative 3 plus 2 equals negative 1. Okay, so that's minus 3 and that is positive 2. And now we can solve for x. X is either equal to 3 or x is equal to negative 2. Now, we've solved for x, but we need to check whether this is actually a valid solution or not. When we looked at the equation initially, do you see that the highest exponent on x was an invisible 1? Meaning there was one possible solution. And then we deliberately squared both hand sides, and then it became quadratic. And now the highest exponent on x is a 2 with 2 possible solutions. So you need to check if 1 is actually invalid. Okay, so let's do that, and we can do this like this. You're going to take the original equation, and we're saying x plus 6 equals x. So in place of x, we're going to substitute these values to check if the left-hand side really is equal to the right-hand side. That's the whole point. Okay, so 3 and 3. Let's see if they will be equal. 3 plus 6 is 9. Square root of 9 is 3. And that is true. Okay, so we know that this is fine. And you still have to test negative 2. So minus 2 and minus 2. 6 minus 2 is 4. Square root of 4 is 2. But 2 is not equal to minus 2. So you see that the left-hand side is not equal to the right-hand side. So in that case, x is not equal to negative 2. And you need to emphasize that, okay, you need to put a strike through that equal to side so they know that that solution is invalid. And that is our answer. And moving on to the next question. Question 1.4 says, use the solution for x in question 1.3 in the previous question to determine the value of y for which the square root of y plus 1 is equal to y minus 5. Okay, so we have to use the solution for x. So the only valid solution we had was this. But for us to use this solution, it's really just like this question. You see how we were able to solve for x here? And then they gave us another equation that looked like this one. And so from that, we were able to spot that, okay, if we just make x equal to p squared minus 1, then, and we replace it there, and we knew what the solutions for x were, we could literally just replace p squared minus 1 with x again at the end of the day, since we already knew the solutions for x, and then we were able to solve for p because the equations had the same form. Okay, so it's really the same thing. So it's kind of like a hence or otherwise question. They want you to use the solution that you got here to determine the value of x for which this equation is true. So the whole goal is, if you have this equation, you can't just start taking, oh, we knew that x was equal to 3 and then trying to work with that. We would need to prove the same thing as we did in the first questions. You have this equation, great, and you're supposed to use the solution that you got in the previous question. But for you to do that, the equations also need to be identical. So let's take what this equation looked like initially, which was this, right? It is the square root of x plus 6 is equal to x. And we need to ensure that this equation looks like that one so that we can draw that conclusion. Okay, so how can we do that? This has an x plus 6 and this just has an x. And how can we make them look identical? Okay, we could use the fact that this says x. And what if we called this x? So we're going to see this as x. So we'll leave it the same. And then you see how this says x plus 6, okay, is equal to x. If this is x, then you need to ensure that in here, because this is x and we're calling x the y minus 5, we need to ensure that there's a y minus 5 in here, but it should still maintain this value of y plus 1 at the end of the day. So let's think about how we could do that. If we have y minus 5, but you see that under the radical, it says y plus 1. So how do we get this to still say y plus 1? Well, the only way we can do that is if you have y minus 5, simply say plus 6. Okay, y minus 5 plus what gives you y plus 1? It's y minus 5 plus 6. Okay, negative 5 plus 6 is positive 1. And so this is still at the end of the day equal to y plus 1. We're just changing the way it looks, not changing the value of it. So here's what we're doing with this. Okay, so we use this to figure it out. And we're just going to say, we're changing this equation now to this. We're saying the square root of, and under the radical, instead of saying y plus 1, we're going to say y minus 5, and then plus 6. And that's what gives us the y plus 1. So we haven't changed that. And then here we're saying y minus 5. So do you see how it says exactly what the equation above says? It has the same form, okay? We have the square root of a value plus 6 is equal to that same value. Same thing here, the square root of a value plus 6 is equal to that same value. In the same way we were able to say x was equal to 3 or x is equal to negative 2, but clearly we're not going to consider that since that was an invalid solution. This is the same way we're going to take this x is equal to 3 and we're going to use it here. So really what we're doing in this equation is we're letting y minus 5 equal x. Okay, so we're replacing it with x. Or really just spotting that it is equivalent to x in this situation. Okay, so the way that I would be able to, or I would just work around proving this is I would say the minute I got it to this point, I'll just say, since we knew that the square root of x plus 6, okay, showing that it's in the same form, x plus 6 is equal to x, then what this concludes is that x is actually equal to y minus 5. It can be replaced with y minus 5. And if you solve for y minus 5 in this situation, you would get those same solutions for x that you got here. Okay, so we're only going to take the valid solution that we had. We knew that x was equal to 3. Okay, that was the only valid solution we had for this equation, okay, in the same form for the previous equation. So that means that here, y minus 5 will also have one valid solution of 3. Okay, we're just treating y minus 5 as if it's one single variable on its own. You could have treated it as k and it will still look exactly the same as the previous equation. Okay, so y minus 5 is equal to 3, and we can finally solve for y. So this means that y is equal to, we could transpose that -5, and then 3 plus 5 is 8, and that would be our answer. So y is actually equal to 8 because these equations now look identical. So here, since we were able to solve for x, okay, and we found x was equal to 3 was the only valid solution, here, because we were able to make it look the same, but we're just instead solving for y minus 5, then it means that the only valid solution would be y minus 5 is equal to 3 as well, okay? Because y minus 5 is now like your x that you're looking at. Okay, so that is the answer to that, okay? Since we were able to prove this and we were able to show them that x was equal to 3, so you see, that's how we got it to that point. Okay, and that is our answer. Moving on to the next question. Question 1.5 says, a race requires an athlete to run 10 kilometers and cycle for 50 kilometers. Okay, so run and then cycle. Tendani runs at a speed of x kilometers per hour and cycles at x plus 31 kilometers per hour. Okay, so they're just giving us information about this race, which is a two-part race, running and then cycling. Then they tell us that he takes 10 over x hours for the 10-kilometer run. So they tell us the time for the run, and clearly they're not giving us any time for the cycling. The question is express the time he takes for the 50-kilometer cycle in terms of x. Okay, so the first question seems to be pretty simple, but let's just write everything out because we know we will need it for the second question. So let's just put the information down. We see that this race, has two parts. There's running and then there's the cycling. Okay, so I'll just call the cycle. Okay, so that's for running, and then I'll just put a symbol for cycling. Okay, so just in case we'll need it, we'll see. So here's what's going on. In this race, we have the running being the distance is exactly, so D there is 10 kilometers. Okay, so he has to run 10 kilometers. And then what else do they tell us about the running part? They tell us that he runs at a speed of x kilometers per hour. So they tell us the speed, which is x kilometers per hour. Okay. And they also tell us he takes 10 over x hours for the 10-kilometer race. So they also tell us the time, 10 over x hours. Okay. And then for the cycling, what do they tell us? They tell us that it takes him a distance of 50 kilometers. So he has to cycle 50 kilometers at a speed of x plus 31 kilometers per hour. So that is what we have there, x plus 31. And that is our speed, kilometers per hour. Okay, they just put a bracket here so you know that it's for the entire x plus 31, not just the 31. Okay. And then they just don't give us the time here, and we need to express this in terms of time. Well, look at how they expressed the time here. They told you that the distance was 10, the speed was x, and then they expressed time as 10 over x. Even if you didn't know the formula, in this case, you would know how to calculate it. Distance over speed is equal to time. But you could also remember this formula. And you can remember it by remembering this abbreviation, DSTV. Okay. So distance, speed, and time. So if you see distance here, to calculate distance, you must say speed times time. And if you are trying to calculate time, you must say distance divided by speed. Likewise, if you're trying to calculate speed, you say distance divided by time. Okay, so that's how we would find the time. Okay, in this question, all we have to do is say, okay, to find the time, we'll simply take the distance, okay, which is 50 kilometers, divided by the speed. And then that is x plus 31. And this will be the time in hours. Okay, so that is the time. And moving on to the next question. And our question 1.5.2 says, calculate the speed correct to 2 decimal places at which he must run to complete the entire race in 2 hours. Okay, so we've done most of the work already, and it just seems like they only want, so they want you to calculate the speed. But remember what the speed was, right? They told us that the speed was x kilometers per hour. Okay, so x is your speed. And they want you to find x, so in other words, they're saying find x, correct to 2 decimal places, at which he must run to complete the entire race in 2 hours. Okay, so because we need him to complete the entire race in 2 hours, regardless of how far he runs and stuff, he needs to still complete the race in 2 hours. This means we're working with the time. So we know that it will take him a specific amount of time to run and then to cycle. But all in all, this race must be completed in 2 hours. So let's take the time of both parts of this race. It takes him 10 over x amount of time, okay, amount of hours to run, and then it takes him this amount of time to cycle, and we're going to take those 2 times and add them together. So we're saying 10 over x plus 50 over x plus 31, because that's the time it's going to take him to run, and that's the time it's going to take him to cycle, and all of this needs to be done in exactly 2 hours. So that is our equation. Okay, the equation is based on the time, and it will help you to solve for x, which is the speed. Okay, so we just need to solve for x in this question. Let's go. Let's see the quickest way we could solve for x. We could just find the lowest common denominator. Okay, so you can see that the denominators we have here are x and then x plus 31. So the only way to make them the same is to make it x times x plus 31. Okay, so that's our common denominator. So both values are going to be here now because they'll be over this. But you have to think about the first fraction. The denominator was x. How'd you get the denominator to be x times x plus 31? The only way you can do that is to multiply it by x plus 31. But you must do that in the denominator and in the numerator. So the numerator will become 10 multiplied by x plus 31. And then now here with this fraction, you see that the denominator was x plus 31. How'd you get this denominator to look like that? By multiplying it by x, okay? But you do that in the denominator and the numerator. So that numerator will become plus 50 times x, which is x, okay? 50x. And then we have 2. But 2 has a natural denominator of 1. So, of course, to get its denominator to look like this, you must simply just multiply it by this LCD, okay? So that will become 2 multiplied by all of this, which will just be 2x and then x plus 31, okay? Because we're just multiplying it by x times x plus 31. And this is what we have. And, of course, the denominator would also be the same. It will be x times x plus 31. And now that the denominators are the same, you can actually get rid of them. You can drop them. This is exactly the same thing as multiplying both hand sides by this common denominator. So because it's in the denominator, if you say times x plus 31, it will cancel with that. Likewise on this side, it will also cancel with that. So that's what we're doing here. And now I'm just going to distribute here. So this is 10x and then plus 310 and then plus 50x. Is equal to, and that distributes and becomes 2x squared, and then positive 62x. Okay, so let's just transpose what needs to go over. We can take everything over to the side. So we still have 2x squared here, positive 62x, but then these two are like terms, so they become 60x, okay, and come over and become negative 60x, and then there's 310, so negative 310 equals 0. Therefore, we have 2x squared. They subtract and become a positive 2x minus 310 equals 0. And we have a common factor of 2 all through, so we can just divide both hand sides of the equation by 2. Therefore, x squared plus x, and then that just becomes negative 155 is equal to 0. And we're not even going to bother trying to solve for x here. Just use the quadratic formula because you can see that they said correct to 2 decimal places. So here's the quadratic formula. Okay, so x is equal to, and we have negative and b is 1. So 1 plus minus the square root of 1 all squared minus 4 multiplied by a, which is 1, and c is negative 1, 55, all over 2a. So 2 times 1. Okay, so let's go ahead and put that on the calculator and see what we get. Okay, so trying the plus first, we get x equals 11 point. And so this third decimal of 9 is going to round that up to a 6. So 11.96, okay, round off to, they said, 2 decimal places. Or x is equal to, and then this is negative. So we'll make that negative. Okay, so you're already getting a negative speed, which we know it's not going to work. So that's also going to be 96. So we'll reject this answer and we'll accept the positive. So it means that x is simply equal to 11.96 kilometers per hour, since we know that x is the speed. And that's how we solve for x in this question. And that is it for question 1. Question 2 says, in a geometric series, the sum of the first n terms is given by Sn equals, and we have k times 1 minus 1 over 2 raised to the power of n. Okay, so it multiplies by all of that. And the sum to infinity of the series is 10. Okay, and they want us to calculate the value or values of k. So they tell us the sum to infinity is 10. That's probably the main point of this, because you see the sum to infinity is the only place now we can actually get an equation that'll help us solve for k. So remember that sum to infinity equals a over 1 minus r. We have the sum to infinity, so we have a value to put here. We just need to find a and r, and we'll have a full equation, and it will probably be in terms of k. So we need to find a and r. R is easy to spot because it's whatever has the exponent, okay? It's always going to be like that because it is the ratio, okay? Whatever is carrying the exponent, that's going to be what you're multiplying to get to the next term. But you need to always make sure that it is raised to the power of positive n, okay? If it's a negative n, here's what I mean. If it was 1 over 2 raised to the power of negative n, there's a little bit of adjustment you need to do here. It needs to be raised to a positive exponent, so that is what you're multiplying by to get to the next term. So in this case, you would have to take that n out as a common factor in the exponent, and you're taking 1 over 2 and raising it to the power of negative 1, and you're saying times that exponent of n. Then if you apply this here, this would be 2 raised to the power of n, okay? There's that n outside. And so this has become 2. So that's what I mean by that. It needs to be raised to the power of positive n. So I can see here straight away r is equal to 1 over 2. I can also see now that to find a, all we have to do is, it's the sum of series they gave you. If you had to find the sum of 1 terms, okay, it's just 1 term, that would be the first term, and that is a. So that's what we can do here as well. Just find the sum of the first term. So s of 1 equals, we say k, times 1 minus 1 over 2 raised to the power of 1. Okay, trying to find the first term. And then raised to the power of n. Okay. And then, yeah, just like that. So this is what we have. The sum of the first term, aka the first term, is simply equal to, this will become a half. 1 minus a half is a half. And then times k is just a half k. So this is a half k. And that is our first term. A is a half k. So we have a, we have r, we have the sum to infinity. We can find this. Okay, so I'll just rewrite this formula here, saying the sum to infinity is equal to this. And we know the sum to infinity is 10. Okay, so we'll say 10 is equal to, and a is a half k, and we have 1 minus r. So 1 minus our ratio is a half. So 1 over 2. So this is 10 is equal to, and we have a half k. 1 minus a half is a half, so we're dividing by half. You can just use tip and times. So you tip this, swap the numerator and denominator, and then times, change the division to a multiplication. See that here, 2 and 2 would cancel, and you just have 1k times 1, which is just k. So k is actually equal to 10, and that is our answer. Moving on to the next question. Then the next question says, calculate the second term of the series. Okay, despite the fact that we don't really have, the Tn formula, we have the Sn formula. The SN formula is very useful, and we can actually just use it to find all the other terms. Here's the thing. You see, let's just rewrite it, right? SN equals, and we'll just substitute K, okay? That's 10. So this actually says 10 multiplied by 1 minus a half raised to the power of n. And here's what we can do. To find the second term, okay, to find a term in a pattern, look at how you can do this. If you have the sum of the terms, you can actually do this. The sum of two terms is made of term 1 plus term 2. So if you wanted to find a term 2, just take the sum of one term, which is just term 1, and you could just say, okay, sum of two terms minus the sum of one term. And then that's just going to be, you see how you're taking the sum of two terms, which includes term 1 and term 2. Term 1 and term 1 will just cancel. And you're left with just term 2. And that's how you will find the second term. So that is the formula. We can just say, to find this, we'll just say the sum of two terms minus the sum of one term. That will give you the second term. Okay, this will always work like that. If you wanted to find, for example, the third term, you take the sum of three terms minus the sum of two terms. Because here you know you're going to have term 1 plus term 2 plus term 3. And then here you know you're going to have term 1 plus term 2. If you're saying all of this minus this, whatever is common will cancel and you will be left with term 3. Okay, so that's how that works. And this is what we're going to do. So to find the second term, and so this is 10 times 1 minus a half raised to the power of 2. Okay, so I'm saying the sum of two terms. So that's 2. And then we're going to say minus, and you're saying minus the sum of one term. So in place of n, we substitute 1. So that is 10 multiplied by 1 minus a half raised to the power of 1. And we would find our answer like this. I'll just find them separately first. So that's going to be 10 times 1 times, okay, 1 minus a quarter is, that's 4 over 4 minus. So that's just going to be 3 over 4, right? So you have 3 over 4 there, and it multiplies to the 10. 10 and 4 have 2 in common, so that's going to be 5 there and 2 there, meaning 15 over 2 is what you have here. So 15 over 2 minus, and we just do the same there. And then we have 10 multiplied by, so that is, this is going to be 1 minus a half, which is a half, and then 10 times a half is 5. So this is 5. Okay, so 15 over 2 minus 5, and term 2 is finally equal to, let's see, you can rewrite this with a denominator of 2 by putting it over 2, so times 2 like that. And so that's going to be 10. So that's 15 minus 10, which is 5, and the denominator stays 2. And there we go. Term 2 is equal to 5 over 2 using this method. Okay, and that is our answer, and that is it for question 2. Question 3, 3.1 says, prove that in any arithmetic series in which the first term is a and whose constant difference is d, the sum of the first n terms is equal to this. So they want you to prove the sum of terms formula of an arithmetic sequence or series. Okay, so to prove this formula, this would usually be in the beginning part of your textbook, you know, in sequences and series, because that's what you start off with in term 1. So to find this, okay, to derive this formula, this is how it works. We're trying to find the sum of terms, but specifically of an arithmetic series. So you need to think about what the terms in an arithmetic series look like. And we're going to write them in terms of A and D. Okay, so you know how A is the first term. So if you had terms in an arithmetic series, to find the sum of n terms, we would say term 1 plus term 2 plus term 3 plus term 4. But here's the thing about this series. You see, A is term 1. So in place of term 1, you can just say A. Now, how do you go from term 1 to term 2? It's arithmetic. So what happens is you keep adding something. You keep adding a constant difference. So what this would become is A plus D. And then to find the next term, this is term 2, we're going to say this term plus D. And so you see how that will give us, again, we still have A there. So it's going to be A plus 2D because you have D here and you're saying plus D. D plus D is 2D. So plus 2D. I'll just leave that in blue. And then you keep doing this. The next term would be A plus 3D. Okay, so plus 3D. And this will keep going all the way to the last term. Now, remember, it's the last term, and we're just saying it's the nth term. So the last term would be called Tn. And that is really just the expression for the general term of an arithmetic series or sequence. And that is just going to be A plus n minus 1 multiplied by D. Okay? Really just means that it's following this order. Notice how these are going. This is term 1. This is term 2. This is term 3. This is term 4. Do you notice the relationship between the coefficient of D and the term number? This is 1D in term 2. This is 2D in term 3. This is 3D in term 4. The coefficient of D is always 1 less than your term number. That's why this is A plus n minus 1D, meaning whatever the term number is, just say minus 1, and then that will be the coefficient of D. Okay, so that's what that means. So this is what we have. Now, for the sake of understanding, I'm just going to put the second last term as well. So before this, the second last term would have been A plus, just follow the order. If this one said n minus 1D, okay, the one before it is going to be, if this was Tn, the one before it is going to be Tn minus 1, meaning 1 less. Okay, the term number is 1 less than what this one was. Okay, so if this was like term 20, this is term 19. Okay, it's just 1 less than that. Of course, that's the term number. Okay, so this is going to be A plus, and here we'll have n minus 2D. Okay, because it's 1 less. Okay, so that is what it looks like, because you're saying n minus 1 and you're saying 1 less, so you're saying minus 1, so that becomes minus 2. Okay, so this is what we have, and we're really just going to work with this. Okay, let's see how we would add these up. What we're going to do is, in place of A plus n minus 1 times D, we're going to substitute L, meaning the last term. Okay, it is an easier variable to work with than all of this. So here's the thing. We're going to say Sn is equal to, and we have A, and then plus, and then, we keep saying A plus D. So it's A plus D, and then A plus 2D, and so on. So this is what we keep saying here. And I'll just leave it to the third term, just so we can get a picture of what's going on here. So this is going to be A plus 3D. Okay, so these are our terms. So we have that first term, second, and the third term. Now, with the last term, we're going to call that L. And I should have stated that first. So we need to tell them we're going to let L be equal to A plus n minus 1D. So that is going to stand for the last term. And so what this means is our last term now is L. And what will the term before this be? Well, think about what these terms are doing. Here we have the first term, and this is the last term, right? When we move forward, we keep adding a D to each successive term. So when you're moving backwards, what are you going to do? You're going to subtract a D. So we're going to say L minus D. So this is L and then minus D. Then the previous one before this will be L minus 2D. So L minus 2D. So this is the last term, the second last term, and the third last term. And I'll leave it at this, just so that we can track what's going on here. Okay, so this is what we have so far. We have the 3 first terms and the 3 last terms. And we'll call this equation number 1. And then to form equation number 2, we're just going to rewrite this, but we're going to reverse the order. So instead of writing it as A and then A plus D and then A plus 3D, we'll write it backwards. Okay, so this is L, and then the second last term was L minus D, so that's L minus D, and then the third last term was L minus 2D, so that's L minus 2D, and so on. And then we can see that the third term was A plus 3D, so that's A plus, sorry, I noticed I said 3D, I don't know why I said 3D, this is 2D, okay, 2D, that's the third term, okay, so that's A plus 2D, And then the second term would be a plus d. So that's a plus d. And then, of course, the first term is a. Okay, so this is what we have. And we'll call this equation number 2. And then to finally get to this point, what we're going to do is take equation number 1 and add it to equation number 2. So that will cause this to become 2SN. Okay, and that's where we're getting that 2 in the denominator from. So it's equal to, and you're going to add the first equation with the second equation. So that right-hand side with the right-hand side here. Now, when we're adding each term, look at what happens. You're going to say this first term plus the last term, which becomes A plus L. And then plus, and I'll just put this in a bracket. We're leaving that together. And then here we are at the second term and the second term in this equation. So that's A plus D plus L minus D. And what happens here? Do you see that D and D would cancel and you'll be left with A plus L? Okay, so first term and the second term would stay again. And then in the third term, look at what happens again. You're saying A plus 2D plus L minus 2D. Well, 2D and 2D will cancel and you'll be left with A plus L again. Okay, so A plus L. And this will keep happening. And we keep going. That keeps happening. And you can even see it with these last terms as well. If you take the third, okay, last term, L minus 2D here, and you add it to this third last term in equation 2, A plus 2D, the 2Ds will cancel and you're left with a positive A and a positive L. Okay, this negative 2D is gone. So again, that is A plus L. And we can see that it keeps being A plus L for that third term, the third last term, and the last term, of course. So I'll just write that again 3 times. And now we can see that it's just going to be A plus L regardless of whichever term number this is. So we can finally just conclude that we know that regardless of whatever term number this is, right, it's just going to be A plus L. So regardless of whether it's the first term, it's going to be A plus L. Okay, whether you're summing up the second term, it's going to still be A plus L. Okay, so if you were summing up these two, it would be 2 times A plus L. And so in a nutshell, we're going to say this is N multiplied by A plus L. And that's what we have here. And now to finally get Sn on its own, we can just divide both hand sides of this equation by 2. So divide by 2, and so the sum of n terms is equal to n over 2 and then multiply by A plus L. But do you remember that we substituted in place of L because it looked, big and complicated and we needed something simpler to work with? In place of this, we substituted L. So we're going to rewrite that. That is A plus n minus 1 times D. Okay, and we're going to input this in this formula. So we have Sn equals n over 2. And in place of A, we just still have A. But then, because this has 2 brackets, I'll use a square bracket here. Plus, and now in place of L, we substitute A plus n minus 1 times D. And finally, this means that the sum of n terms equals n over 2. And this is 2a, a plus n minus 1 times d. And that is how we find the Sn formula, the sum of terms, formula for an arithmetic series. Moving on to the next question. Question 3.2 says, calculate the value of the sum of series. Okay, and they give you this formula, 100 minus 3p. Starting at p equals 1, great, and ending at 50. Okay, so it's 4 marks. You can just go ahead and expand it. So we are saying that this series starting at p equals 1, ending at p equals 50 of a series with the Tn formula, the general term 100 minus 3p, that it is equal to, let's substitute in place of p, we're just substituting 1. Okay, so here, if you substituted 1 minus 3 times 1, it's just, 97. So you're going to say this is 97 plus, and the next term you substitute p equals 2, and that's 94 plus, and the next term 3, and that's 91. And in this one, we actually know what the last term is going to be because we know that p equals 50. So substitute in place of p 50, okay, and that is negative 50. So it ends at negative 50. Okay, no problem. So we rewrite it first. And now we can just see certain things from this. We can see that in this series, first it's arithmetic because, 3p, right? The p is not in the exponent. So we can see the value of d is always going to be whatever is the coefficient of p, which is -3. Okay, you can still check. 94 minus 97 is -3, and then so on. So we can see d is equal to -3. No, it's not really necessary to do it like that. You can just use this formula. So it's an arithmetic series. So just use n over 2 and then a plus l. Just use that. Okay, so we know what the last term is. It's -50. So I'm just going to say it's the sum of how many terms. Remember that to find that, in this one, it's quite simple because you're starting at p equals 1, right? You say top minus bottom, okay, that top number minus bottom, which will be 49, and then you just say plus 1. Top minus bottom plus 1. So that is 50 terms. Sum of 50 terms equals 50 over 2. A is 97 plus, and L is, we can say the last term is -50, so -50. And you would find the sum of these terms. So S of 50 equals, and let's find that. And our answer is 1175. And that is it for this question. Okay, moving on to the next question. Question 3.3 says, a quadratic sequence is defined with the following properties. Term 2 minus term 1 is 7. Term 3 minus term 2 is 13. Term 4 minus term 3 is 19. Okay, so you have to actually write this out first. You see, a quadratic sequence has a first difference and a second constant difference. So here's our quadratic sequence. Okay, this is term 1, this is term 2, term 3, and so on. They're saying that if you take term 2 minus term 1, you get 7. So this is the first difference of 7. And then if you take term 3 minus term 2, you get 13. And if you take term 4, so here's term 4, minus term 3, you get 19. So this is the first difference. This is a linear pattern that they've given us here. And they ask us to write down the values of, and the first one is term 5 minus term 4. Okay? If you know what this is going like, you'll be able to find term 5 minus term 4. That is the what term in the first difference. So that would be the fourth term in the first difference. So we just have to find, we don't really need to find a formula. You just see how these ones are going. How did you get from 7 to 13? You simply added 6. So you said plus 6. So we can see that the second constant difference is 6. And then how did you get from 13 to 19? You added 6. And so to get term 5 minus term 4, okay, which is the fourth term in your first difference, you're simply just going to say this constant difference is still going to be 6. So if you add a 6 here, 19 plus 6 is 25. Okay, so that's what that is going to be. This is equal to 25. And then term 70 minus term 69. And yeah, you see, you can't just keep adding 6 and then 6 and you're just going to like, it's going to take really long. So what you can do at this point is actually find the formula for your linear pattern. So here's our linear pattern. It is 7, 13, 19. And how do we find the formula if we know the difference is 6? You can see that the value of A, I don't even need to rewrite it. The value of A is 7. The first term in your linear pattern, the 7. And then D is 6. Okay, so let's write the formula. The Tn formula is A plus n minus 1 times D. So Tn equals 7 plus n minus 1 times 6. And all we're doing is we're trying to find out where will, okay, in the first difference, where will term 70 minus term 69 be? Okay, which term would this be? Well, look at how these ones were going. Do you see that term 5 minus term 4, okay, term 5 minus term 4, that was the what term in your first difference? That was the 1, 2, 3, fourth term in your first difference. So it means that between term 70 and term 69, when you say term 70 minus term 69, which term will that be in your first difference? It's going to be term 69. It's always going to be the lesser one. Okay, just like this one, term 4 in the first difference lied between term 4 and term 5 in the quadratic pattern. So it means that term 69, and term 70 would be subtracted to get term 69 in the first difference. Okay, so that's what that looks like. Okay, so we just need to find term 69. So we'll say term 69, and in place of n, substitute 69. So 69 minus 1 times 6, and we'll find our answer. And that is 415. So we can finally just conclude this means that term 70 minus term 69 is simply equal to 415. And that is our answer. Moving on to the next question. And then question 3.3.2 says, calculate the value of term 69 if term 69 is equal to 23,594. I think they mean Tn. Okay, so I think they mean find Tn. But why would they say value though? Okay, let's just use this as practice to get the Tn formula. Okay, so if they're saying term 69 is equal to this, right? They're referring to term 69 in the quadratic pattern. This is not the first difference. I know the first difference may have 415, but that's this term they're referring to, term 69. Okay, when we say term 70 minus 69, it gives us this term of 415. Okay, term 69 in your first difference. So if they were telling us that term 69 is equal to this, and maybe they were asking for the Tn formula, how would we find that? And the reason I'm just going to go with Tn is because it really doesn't matter. If they were saying find, I don't know, term 78, if term 69 is equal to this, you would still need to find the Tn formula for you to even find term 78. So I'm just going to use this as a practice to find the Tn formula. Okay, so you see Tn, this is the general form of the quadratic number pattern, which is in the form of an squared plus bn plus c. And so you need to find a, b, and c. But you see how your pattern is literally almost complete? You have the first three terms of those patterns you need. Okay, the second constant difference, the first difference, and the quadratic, but you don't have that one. But it's fine because they told you what term 69 was, and we can actually use that. So here's the thing. You know that this is 6. You equate this second constant difference to 2a. And then you equate this to 3a plus b. And this will help to solve for a and b. And only c will be missing, but that's fine because they told us information about term 69. So we can just say 2a is equal to 6. Therefore, if you divide both sides by 2, a equals 3. And then we can say 3a plus b equals 7. So that's 3, and then a is 3 plus b equals 7. That's 9. So b equals 7 minus 9, which is 2, negative 2. And then we don't know what c is, but that's fine. We can just fill in what we have so long. Tn equals, and in place of a, we say 3n squared minus 2n and then plus c. Now we can use this information and what they have given us here. They told us that term 69 is equal to 23,594. I don't know if it's actually equal to this, but it seems like that's what they were trying to say. So in place of n, we're substituting 69. And so we're saying term 69 equals 3 times 69 all squared minus 2 times 69 plus c. I'm not even going to try to calculate this with my head. I'm just going to use the calculator. And then we're going to take that, and in place of 69, we substitute this number, okay? Because this is 69. So we say 23,594, since it's equal to term 69. It's equal to this. Okay, yeah, that's going to get us to the answer at least. So that's 3 times 69 all squared minus 2 times 69. And you see what it gives us. It gives us, so just to make sure I'm writing the right thing. And then you say 23,594 minus 14,145 equals C. And that will be C. So this answer, we're going to say 23,594 minus that answer. Okay. And our answer is 9,449. And that would be C. So finally, Tn is simply equal to, rewrite it and just put C. So 3n squared minus 2n plus 9,449. And then with this, you can find any term they asked for. So if they were actually asking for term 69, if this is equal to that, which would be crazy because they already told you term 69, But regardless of whatever term value they ask for, okay, term 70, term 82, you could always find it because you have the TN formula. Okay, so that is it for this question, and that is it for question 3. Question 4, 4.1 says, given f of x equals x squared minus 2x minus 3 and g of x equals x minus 5, 4.1.1 says, show that the turning point of f is 1 and negative 4. Okay, so how do we find the turning point when the equation of the parabola is in its standard form? We can find the x value of the turning point first by simply saying x equals negative b over 2a. Okay, so we can see that the b value is negative 2, the value of a is 1. So x is simply equal to negative, and we'll say negative 2 over 2 times 1. So that's positive 2 over 2, which is 1. Okay, so that is the x value. So to find the y value that corresponds with this, we're going to take this and substitute it into the equation of the function. Okay, so f of 1, meaning let's find the y value that goes with this x value of 1. So we'll substitute 1 all squared minus 2 times 1 minus 3, and then we'll get our answer. Okay, so you can see that that's 1, that's minus 2, that's minus 3. Okay, that becomes 1 minus 5, which is negative 4. Okay, so that concludes that this is the turning point of f. Okay, and that is it for this question. Moving on to the next question. The next question, 4.1.2, says, determine the coordinates of the x and y intercepts of the graph of f. Okay, so to find the x-intercept, you make y equal to 0. To find the y-intercept, you make x equal to 0. And that's all we have to do there. So let's just rewrite our equation, okay, of f first. And so we're going to first find the x-intercepts. So we're going to make y equal to 0. So x squared, or you can just say 0 equals x squared minus 2x minus 3, and then factorize. So open up 2 brackets. X times x give us x squared. Now we need factors of negative 3 that can give us a negative 2 in the middle. So 3 times 1 is 3, but clearly 1 has to be negative. So you need to ensure that this is negative, so give the negative to the bigger factor. Okay, negative 3 plus 1 indeed is negative 2. So this is minus 3 and positive 1. Therefore, x equals positive 3 or x equals negative 1. So these are our x-intercepts. We can also just write them in coordinates. Okay, they did say determine the coordinates. So the x-intercepts are 3 and 0 and negative 1 and 0. And now to find the y-intercept. So the y-intercept is very simple. You don't really have to make x equal to 0. It's not necessary. If you make x equal to 0, everything becomes 0 except for that constant. So we can see this is our y-intercept. Okay, so the y-intercept is simply, so intercept is simply just negative 3. Okay, so as a coordinate, it is 0 and negative 3. And there we go. So they probably want us to draw the graph. That's why they're asking for all these things. Moving on to the next question. Question 4.1.3, they say, determine the points of intersection of the graphs of f and g. Okay, so one is a parabola, one is a straight line. If you have a parabola and a straight line, to find out where they intersect, this would be where their x and y value are exactly the same. So we're simply going to equate these graphs, or make f of x equal to g of x. So let's just write our graphs down first. Okay, so we'll say f of x is equal to g of x, and we have x squared minus 2x minus 3 equals x minus 5, and we can transpose these. So x squared, and if you have negative 2x already, and then negative x comes over, that becomes negative 3x. And then negative 3 and then positive 5 comes over, so that becomes positive 2. Equals 0, open up 2 brackets, equate to 0. X multiplied by x gives us x squared. Factors of 2 that can give us 3, okay, it's positive 2. And you need to achieve a negative 3 in the middle. So make it negative 2 times negative 1. That's what gives you positive 2, but negative 2 minus 1 is negative 3. So therefore, x is equal to positive 2 or x equals positive 1. So these are the x values of the points of intersection, but they want the full points, so we need to find their y values as well. So remember that at this point, their x and y values are the same, okay? So it means that for this x value of 2, you remember how we showed that they intersect? For that x value, we can simply just substitute this into either one of the graphs because they will still have the same y value at that x value of 2. Okay, so I'll use the graph of g because it's easier. I'll say g of 2 is equal to, and then it's 2 minus 5, okay, in place of x. So that is g of 2 is finally equal to negative 3, okay? Or, and then the second y value we have is g of 1. So that's the x value we have. So this is equal to 1 minus 5, and so g of 1 is simply equal to negative 4. Okay, so our points of intersection are 2 and negative 3. Okay, so those, and here the x value is 1 and the y value is negative 4. Okay, so those are points of intersection. Moving on to the next question. Question 4.1.4 says, sketch neat graphs of f and g on the same system of axes and then clearly label the turning point and where the graphs of f and g intersect. Okay, of course, intersect each other as well as the x-intercept and the y-intercept of both graphs. Okay, x-intercept and y-intercept of both graphs. I'm just going to assume that one of the intercepts probably happen at this point of intersection, but we'll see. Okay, we still need to find the x and y-intercept of the graph of g. So you can see that its y-intercept, okay, the graph of g has a y-intercept at this point, negative 5, okay, because you can see that c is negative 5. If you made x equal to 0 to find the y-intercept, you just get negative 5 at the end. So at 0 and negative 5, and where is its x-intercept? Okay, the graph of g, to find its x-intercept, you make y equal to 0. So g of x becomes 0 equals, and then x minus 5. If you transpose that, x is just equal to 5. Okay, x equals positive 5. So the x-intercept is 5 and 0. Okay, it's not the same, but at least we know them now. So I'm going to go ahead and draw our Cartesian plane first. And let's go ahead and start with the graph of f. So the graph of f, here are the intercepts, 3 and negative 1, and the y-intercept of negative 3. Okay, so 3 and negative 1. So negative 1 is here. You can go ahead and we'll put that point down. That is negative 1 and 0. And then 3, let's just make that over here. So that is 3 and 0. And then a y-intercept of negative 3. So negative 3 is, we can just put that there. That's negative 3. So that is 0 and negative 3. And then it also had a turning point, remember. So the turning point was 1 and negative 4. So 1 and negative 4 would be 1 and then 4 down. So over here, 1 and negative 4. It just has to be in between these two x-intercepts because it's going to be the halfway point. Okay, so 1 and negative 4. And these are all the points for the parabola. And now we can just go ahead and sketch our parabola down. Okay, so remember, you can just draw from a wing to a wing. Start with the, the little bit more challenging one. So from the turning point, go to the y-intercept and then hit the x-intercept and shoot up. And then here from the turning point, just hit that x-intercept and go up. Okay, so like that. And then the graph of g. So we already have its x and y-intercept as well. So let's just put those down. So the x-intercept is 5 and 0. So that's from 3, 4, 5 and 0. So 5 and 0. And the y-intercept is simply 0 and negative 5. So this is negative 4 here, that's y value. And then negative 5 is over here. So that's 0 and negative 5. And so you're just, with your ruler, you're just drawing a graph that connects these 2 points. So just go from there to there. I may not get it right on the first try. So, and then just, well, the ruler is easier because you can already see what's going on. And so you can just connect them once you're there. Okay, so those are 2 graphs. And that's really all they want us to do. So just make sure you label the graphs. This one is f and this one is g. Remember, they intersect at these 2 points. Okay, 2 and negative 3 and then 1 and negative 4. So that's here and here. So the x value that is smaller is the 1. So that is the 1 and negative 4. Interesting. So it intersects here with this same y value of -4. 1 and -4. And then this one is the 2 and -3. So that's 2 and -3. And I'll just put those down. Moving on to the next question. Okay, question 4.1.5, which seems like the last question concerning this. They say, use the graph to determine the values of x for which f of x is greater than or equal to 0. Okay, let's understand something about f of x quick. You see, when you have a graph on a Cartesian plane, right, regardless of what that graph looks like, f of x stands for the y values of the graph, where you find y values on the y-axis. Okay, so when they say where is f of x greater than 0, you're simply looking for where the y values of this graph are positive, okay, greater than 0. You know that you only have positive y values all through here is all positive. And we have negative y values all through here. Now, what do you notice about where these positive y values are? They lie above the x-axis, okay? Everything above the x-axis has positive y values. Everything below the x-axis has negative y values. So if you're ever looking for where f of x is greater than or equal to 0, look for parts of the graph that lie above the x-axis. And then if it's f of x is less than 0, look for parts of the graph that lie below the x-axis. Okay, so that's what you need to keep in mind for this question. So let's see, where is f of x greater than or equal to 0? I'm only looking for parts that are above the x-axis. So here's how I'm going to spot this. That's above the x-axis. That's below the x-axis. Not taking any of those parts of f. And then that's above the x-axis. Okay. Now also just remember they said greater than or equal to 0. So it means that y can also be equal to 0. The places where y is equal to 0 are at your x-intercepts. Okay, here, there's the y value 0. There, the y value 0. Okay, so that means that what works for this, you can simply line it down to the x-axis to understand the values of x for which this works. Okay, and we can see that they're moving to the left-hand side of -1. This is -1 here. Okay, on the x-axis, it's to the left of -1. So these are values that are less than -1. Okay, so we'll say x is less than -1, or, and then do the same to the other wing that we have, the other part selected. Line it down to the x-axis, and you can see that these are values that are moving to the right-hand side of 3. So these are values that are greater than 3. Okay, so x is greater than 3. But don't forget now the equal to as well, because at these points, okay, we have y values of 0, and they want you to solve for x for which f of x is greater than or equal to 0. So x is less than or equal to -1, or x is greater than or equal to 3, and those are our answers. And moving on to the next question. Question 4.2 says, the graph of f of x is equal to 1 over 3 raised to the power of x is sketched below. So this is an exponential function. And they want us to write down the equation of the asymptote of f. Remember, this is an exponential function. It only has one asymptote. It's not like the hyperbola, okay, that has two. It only has specifically a horizontal asymptote. You can see that there is a point, okay, there's a line that this graph will literally just never touch. And right now that is the x-axis. But you don't look at it by just staring at it and saying, I think it's moving closer to this. Yes, in this case you can do that, but mostly focus on the equation. The equation of the exponential function should be in the form of, it's in the form of y equals a multiplied by the base raised to the power of x, and then minus p, because sometimes there's a left or right shift, and then plus q. Now this plus q, that's what tells you your horizontal asymptote. Right now, do you see any plus q? Do you see any plus any number? No, and that's because the value of that number is 0. So it means that that asymptote is at 0. Now it's a horizontal line. The way you write the equation of a horizontal line is you start with y is equal to, because horizontal lines pass one particular y value. They have multiple x values. See, x values all through, but one particular y value. So the equation of that asymptote is y equals 0. And that is our answer. Moving on to the next question. Question 4.2.2 says, write down the equation of the inverse of f in the form of y is equal to. Okay, so let's just rewrite the equation of f in the form of y equals, so that's 1 over 3 raised to the power of x. And so to find the inverse, you first swap x and y. So in place of y, we say x, and then it's equal to 1 over 3 raised to the power of, in place of x, we say y. And now we need to make y the subject. To make y the subject in an exponential equation, you are going to use log. So we'll say log, and the base we have here, okay, whatever was carrying the exponent is 1 over 3. And the answer that we had was x. Okay, the bracket don't need to be here. It's really on the x, but it's not necessary. So this is our answer. Log x to the base of 1 over 3. Moving on to the next question. Question 4.2.3 says, sketch the graph of the inverse in your answer book, indicate the intercept, and one other point. Okay, so with the inverse, it really just does whatever the exponential does. Okay, it's just going to do that on the other axis. So here's our exponential function. We can just find this y-intercept first. Now, straight away, I already know it's going to be 1 because, anything to the power of 0 is 1. But also, there was no shift here. So the next place that it will move up, if this is at y equals 0, is simply at 1. It's always just going to be like that. So I know this is 1. And so we know that if the y-intercept is 0 and 1 on the original function, on the inverse, what this point will look like is the x and y values will swap, just like when finding the equation of the inverse. Okay, it's just going to be 1 and 0. So we have an x-intercept. Now think about it. Will you have a y-intercept? For you to find out whether you are going to have a y-intercept with that graph is, can you have an x-intercept with this graph? No, because this graph will just move closer and closer to that asymptote of y equals 0. So it's never going to touch the x-axis, therefore it will never have an x-intercept. If you had an x-intercept on this graph, it will become the y-intercept of this graph. Just like we saw, we had a y-intercept on the exponential, the inverse will have an x-intercept. So it means that this can't have a y-intercept either, because this can't have an x-intercept. Okay, so you only have this point. But they said indicate the intercept and then one other point. So we'll just find another point. It's best to find a point that can help you with the shape. So since we have this point over here, I'll find a point on this side. Okay, so let's just try -2. I'll just try -2. And let's see what we get. So the graph of f, right, when it's equal to -2, f of -2, we have 1 over 3 raised to the power of -2. What does that give us? F of -2 would be equal to, that's going to be 9. Okay, so positive 9. So it means that on the graph of f, you have this point -2 and positive 9. So what will that point look like on your inverse? That point on the inverse would simply be 9 and -2. So we have 2 points here. We have this point and we have an x-intercept, and we can draw our graph. So put down the Cartesian plane first. Okay, and let's just put down our 2 points. So we first have, there's actually one thing we need to put down that is actually important. Here, you see here how we have a horizontal asymptote. The inverse will not have a horizontal asymptote. It will have a vertical asymptote. So if this one's horizontal asymptote was y equals 0, the inverse's vertical asymptote will be x equals 0. Okay, so y equals 0, instead it becomes x equals 0. So it will have a dotted line here, but we're not going to draw it down. I'll just write the equation. X equals 0, and now we can put down our points. So the first point we have, I'll just start with that, is 1 and 0. So that's, 1 and 0. And then the other point is 9 and -2. Okay, so positive 9 and -2. I'll just put that like here. Okay, positive 9 and -2. You can already see the shape that this exponential is taking. Okay, it's going to move like that. But in a nutshell, how it works is, if this one, okay, just look at where it is. Where it is, okay, where the x values are negative, it starts off with a positive y value, okay, a high positive y value. It means that with the inverse, it's just going to switch places, okay? So whatever x was, that's what y will become. So here, on the negative part of the y-axis, it will start off with a positive, a high positive x value. And then it will just do exactly what this one is doing. So if this one went down, moving towards the positive part of the x-axis, this one will go down, moving towards the positive part of the y-axis. Okay, so that's what it does. And we can just go ahead and draw our graph. So connect it, goes down like that, and moves closer and closer to this y-axis. Okay, so something like that. And that is the inverse of the graph of f. And moving on to the next question. Question 4.2.4 says, write down the equation of the asymptote of the inverse, okay, if this was applied to it. So you're adding to the x. Think about, well, it's just about the asymptote at the end of the day. Think about what the asymptote of the inverse looked like. The asymptote of the inverse was a vertical asymptote, okay, this, and it says x equals 0. So if you have x equals 0, and they're just saying, hey, we're going to take to all the x values, we're just going to say plus 2, okay? What you're doing here is you're applying a shift, and it's a shift affecting the x. Let's first speak about translating the shift, and then we would apply it to this Cartesian plane, to the graph specifically. So if we have x and we are adding to the x, first of all, if you are adding or subtracting to an x value, it means you're moving to the left or the right. Okay, if you have a point, let's say 1 and 2, and I say, let's move this point 2 units to the right. If you go from this point of 1 and you go 2, 3, you have a new point at 3 and 2. Do you see that the only thing that changed was the x value? The y value is still the same. So left or right movements only affect the x. So let's just translate what happened. We said x plus 2. So if you move to the left, you add, okay? So apply this to the equation. You say plus. And if you're moving to the right, you would subtract. This is not the same with up and down. With up, you just add. With down, you subtract. Very simple. Okay, so with the left and right, just remember that it's the other way around. Okay, so they say x plus 2, so it means that this graph was shifted how? 2 units to the left. Okay, so we'll keep that in mind. Tell them that this was shifted 2 units to the left. Okay, so this is a shift 2 units to the left from the inverse. So think about that. If it went 2 units to the left and it's affecting the x, your vertical asymptote, okay, the asymptote you have there was a vertical one, and it was x is equal to 0. So that's going to move 2 units to the left. So you have this over here, the vertical asymptote of x equals 0, and it moves 2 units to the left. So it becomes 1, 2. I moved the wrong graph. Okay, so 1, 2, and it will become x equals negative 2. Okay, move 2 units to the left. And that is the equation of the asymptote. It's simply x is equal to negative 2, and that is our answer. Okay, remember, if you apply to the x, you are shifting it to the left or the right. If you are adding or subtracting. And then just remember how that goes. Left is plus, right is minus. Okay, and so you're going to translate it first, think about what it says, and then apply it using the graph. So that is our answer. Moving on to the next question. And question 4.2.5, the last question for question 4 says, prove that f of x all squared minus f of negative x all squared is equal to, okay, so the left-hand side is equal to this right-hand side, which is f of 2x and then minus f of negative 2x. Okay, so we're just going to have to apply this and then see if it really does equal this in our graphs. So the graph of f of x, that was the 1 over 3 raised to the power of x. We already had that. So let's get I'm just going to rewrite that first. That's 1 over 3 raised to the power of x. And we can just rewrite this left-hand side first and just apply that. So if this is f of x all squared and then minus f of negative x all squared. Okay, so they're just saying if you had to square this, right? So apply the square to this. It's exactly the same as if you were replacing x in place of x, putting a 2x here and then putting a negative 2x into the second one when you subtract it. That's really what they're saying. Okay, so just prove the left-hand side is equal to the right-hand side. So let's go ahead and substitute. We're saying f of x all squared. So this is 1 over 3 to the power of x, 1 over 3 raised to the power of x, and then you're saying all squared. Okay, and we know what happens when we square exponentials. So minus, and we have 1 over 3. Okay, but with this one, they put a negative x here. Okay, so in place of x, you're going to substitute negative x instead of x. Okay, because this f of negative x. So whatever is here, that's what we apply to x. So raise it to the power of negative x and then all squared as well. Okay, so all squared. I'll just make that one blue, and then, the squared, just leave it red. Okay, so this is what we have, and we can apply this. This has a negative exponent, so I'm just going to rewrite it so that it has a positive exponent. And if you apply this here, it just becomes 1 over 3 raised to the power of 2x. And then this becomes, so long, it's just 1 over 3 raised to the power of negative 2x. At this point, we could just find out whether this one also looks like that, really. I don't really see a use of writing it in a format where the exponent is positive, because if we directly substitute at this point, you're going to see it looks exactly the same. Okay, so if you take the right hand side and we have f of, so let's just rewrite what we have there. It says f of 2x, okay? And then here, minus f of negative 2x, so negative 2x. And we know that f of x is 1 over 3 raised to the power of x. It just means that wherever you see x, replace it with 2x, okay? F of 2x. So here, this will be 1 over 3 raised to the power of 2x. And then minus, and this is f of negative 2x. Wherever you see x, replace it with negative 2. So 1 over 3 raised to the power of negative 2x. Okay, so negative 2x. And that would be it. Do you see how they look exactly the same? The left-hand side and the right-hand side are equal. So we can finally conclude the left-hand side is actually equal to the right-hand side. So there we go. We have proven that this equation is true. Okay, left is equal to the right for all values of x. Okay, so you can just conclude that. Take this side is equal to that, where x is an element of all real numbers. And then I'm going to say where x is an element of real numbers. And that is our answer. And that is it for question 4. Question 5 says the diagram below presents the graph of f of x, okay, which they have finally put in its original standard form, okay? You don't have to overthink anything here. And we have this point T on the graph as well, which is 5 and 3. And they also tell us, it seems like they tell us the values of the asymptote. Okay, so with this one, it seems like, this may have been somebody who just wrote the answer. But yeah, we can see the answer now. It passes, okay, a vertical line that passes 4 is your vertical asymptote. So x equals 4. And then a horizontal line that passes 2, so y equals 2. I'm not sure if that was, in the exam already given or not. But yeah, regardless, it's something that we can see. You just need to remember what they are though, okay, and what they stand for. 5.1 says determine the values of A, P, and Q. Okay, very simple. All you have to do is find P and Q first. We can see the vertical asymptote is x equals 4. That is your value of P, and this is already in its standard form. So P is simply equal to 4. And then your horizontal asymptote is y equals 2, so that is the value of Q. Q is equal to 2. So just tell them P is equal to 4, Q is equal to, and Q is equal to 2. And then just find the value of A. They gave you a point. So let's fill in our equation. Our equation is now f of x equals A over, and then we have x minus P, but P is 4, so minus 4, and then plus Q, which is plus 2. And just substitute the point of T, which is 5 and 3. And you're going to put that in place of x and y, so to find A. So this is 3 equals A over, and we have 5 minus 4 plus 2. And we can transpose that 2. So 3 minus 2 is 1. We have A over 5 minus 4 is 1. So A is just 1. Okay. So A is finally equal to 1. And that is our answer. We can just say A equals 1 like that. So P equals 4, Q equals 2, A equals 1. Moving on to the next question. Question 5.2 says, if the graph of f is reflected across the line having the equation y equals negative x plus c, and the new graph coincides with the graph of y equals f of x, determine the value of c. Okay, so the graph of f is reflected across this line y equals negative x plus c. So this graph of f, this hyperbola, it gets reflected across a diagonal line because it says y equals negative x plus c. So it's a line with a negative gradient, and lines with negative gradients, they decrease. Okay, if the gradient was positive, it would be an increasing function. When you read it from left moving to right, it would be increasing. Okay, so this one is decreasing. So I'm just going to say, let's say it looks like this. But in a nutshell, what they're saying is they're going to take this graph and they're going to reflect it, right? And it's going to be reflected across this line, and it's just called y equals negative x plus c. And once they reflect it, that reflection, the graph that you reflect, it's going to perfectly align with this current graph of f. So we're taking this graph, we're not just reflecting it across the line y equals x, okay? No, we're reflecting it across this particular line, which we don't know what c is yet. But when we do that, it ends up coinciding with this. I think the best way I can show this is I need this to be like an image first, like a picture. Let me just get a picture of that. Okay, I'll try my best with this. For it to coincide, okay, so it gets reflected across this line. So if this is the line here, when this is reflected, it will appear here. But then when it appears here, when it's reflected, it coincides, meaning it perfectly aligns with this graph. So this is kind of an idea of what it does. It's going to get reflected, okay? So it's going to appear over here, but it's going to meet perfectly with this line. You see how that was just done immediately? From this point, it gets reflected and then perfectly coincides with this one. So it means that, and let me just delete this now, it will perfectly align with this one. So it will line up perfectly like that. The only way you can reflect a hyperbola and it lines up with the other wing, and of course this one will line up with that wing, the only way that is possible is if you reflect it across one particular line. And that is called the axis of symmetry. That is the axis of symmetry. And so what we're trying to solve for is C, the y-intercept of the axis of symmetry. So you just need to think about, how can I find the axis of symmetry of this graph? Okay, how do we find that? And you see how that makes perfect sense. It's the axis of symmetry. It's the line that cuts the graph symmetrically. So this part looks exactly the same as that part. That's why I was able to take that and then reflect it, and then it fits perfectly onto this one. Because what this does the exact same thing. And that's what an axis of symmetry shows you. It shows you that these two, they do the exact same thing, cut it into two equal parts. Two equal halves that are identical. So what they're really just asking for in a fancy way is find that y-intercept of your axis of symmetry. Now notice this is the axis of symmetry with a negative gradient. How do we find the equation of that axis of symmetry? Well, we can find that by saying if this is y equals, okay, it's negative x plus c. But think about what the equation of the negative axis of symmetry is. The positive one, if you remember the general form of a hyperbola, you can remember the positive axis of symmetry, the one with the positive gradient. Okay, the general form of a hyperbola, which they already gave you here. They were being so nice with this. They said a over x minus p plus q. Okay, so if you know that, the positive one is y equals positive x minus p plus q. So the one with the negative gradient, that is y equals, now it's still going to look like this. It's still x minus p plus q technically, but what happens is a negative goes in front of x minus p. And so it becomes y equals negative x plus p plus q. And that's what we need to work with. It's the one with a negative gradient because you can see they gave us an equation with a negative gradient. Okay, y equals negative x plus c. So our equation of the axis of symmetry is negative x plus p plus q. And that's all you needed to remember. And then we'll fill in p and q. Okay, We know that P is, we found that to be 4 and Q is 2. So it's just y equals negative x plus 4 plus 2. Therefore, y equals negative x plus 6. And this is the equation of this axis of symmetry, meaning C is what? So therefore, the value of C they were referring to is 6. And that is our answer. 6 is our answer. And that is it for question 5. Question 6, 6.1 says, given f of x is equal to 3 minus x squared, use the definition, or really from first principles, of the derivative to calculate f prime of x. So remember, to find this, okay, using the first principles method, you still need that second y value, okay, when finding this average gradient. So we're going to find f of x plus h. Okay, so in place of x, replace it with x plus h. So we have 3x, so we say 3 times x plus h. And then minus x squared, x plus h all squared. And let's just simplify. So this is going to be 3x plus 3h and minus. Now this has to be distributed. You can write it twice and then FOIL out, or you could just do this. So x gets squared and becomes x squared. The last term gets squared and becomes positive h squared. And then first term times second term is xh. Then you just multiply that by 2. So that is positive 2xh. And then that negative goes in. So we have 3x plus 3h minus x squared minus 2xh minus h squared. Okay, and now we can write down our formula. So to derive this using first principles, we say f prime of x is equal to the limit as h approaches 0, and we say f of x plus h minus f of x all over h. Okay, so this is f prime of x is simply equal to the limit as h approaches 0, and we say f of x plus h, which is everything here. So I'm just going to copy and paste that. All of that, and then minus f of x. So you're subtracting by f of x, but f of x has 2 terms, so remember to protect it with brackets. So you're subtracting by 3x minus x squared. Okay, and then this still goes all over h. So just be careful when writing these. So the limit as h approaches 0, and you're going to rewrite everything that you had already, but then you see that this distributes in and just becomes negative 3x and positive x squared still over h, and now we can just cancel out whatever is common. So this is now the limit as h approaches 0, and you can see what will cancel. It's whatever you were subtracting by. So this would cancel with this, and the negative x squared cancels with the positive one. And all we're left with is 3h and then minus 2xh minus h squared all over h. And this is equal to the limit as h approaches 0. And you see, now we can solve the problem that we initially had. The h was in the denominator, so we couldn't even evaluate, okay? We couldn't substitute in place of h, 0. We couldn't do that. So now we can finally take h out as a common factor. And what were we left with in the first term? We're left with 3. The second term, we're left with negative 2x. And in the third term, that is just negative h all over h. And then it cancels, and now it's gone. And now at this point, you can just decide to substitute. I'll just write it one more time. Limit as h approaches 0, 3 minus 2x minus h. And now finally, f prime of x, we can evaluate. This is 3 minus 2x minus 0 in place of h. And so f prime of x is finally equal to 3 minus 2x. And that is the gradient of this function at any point. Moving on to the next question. Question 6.2 says, determine dy over dx if, okay, y equals this. So think about it. Can you find the derivative at this point? Not yet. So it needs to be prepared. We still have a third with x, okay, under the radical. We still have an x in the denominator. We need to fix those. So let's rewrite this as y equals. We can start by separating these, okay? There's a minus because you had two fractions with the same denominator, and you just put them together over their common denominator. So we can separate them by writing this separately. So this is x over that denominator, x squared, and then it's minus, and we have 3 square root x over x squared. Now, of course, at this point, you can also fix this. So we can't really have a set and then derive, because then, we can't really use the power rule. So what we're going to do is we're going to rewrite this so that it has a base and then a rational exponent. So the base is x, but the exponent is going to be, think about what the inside exponent of the third is. The x has a natural exponent of 1, and this is a square root. So this is a square root, not cube root. So you wouldn't have 3 here, you would have 2. So to write that exponent as a rational number, we would say the inside exponent, which is 1, over the outside exponent, which is 2. Okay, so this is what we have. And now we can just simplify a bit further, fix everything that needs to be fixed, and this should be fine. So we have y equals, here we can just divide. So we say x and the bases are the same. So when your bases are the same and you're dividing, you need to subtract your exponents. The exponent on this x is an invisible 1. So it's 1 minus 2. And 1 minus 2 is negative 1. So this is what you have, x to the power of negative 1. It's not in the denominator, it's just written like that because once you start dividing, whatever you divide by, after you have divided, that quotient is just going to be in the numerator normally. And then you have minus and 3. Okay, same thing here. I have an x. So we're going to say top minus bottom. Okay, that exponent minus the bottom exponent. So x to the power of, what is a half minus 2? It's negative 3 over 2. And now we are ready to derive, and we can go ahead. Using the power rule, we'll say dy over dx is equal to, and we're going to say coefficient times exponent, which is negative 1, and then we still have x, exponent minus 1, negative 1 minus 1 is negative 2. And then coefficient times exponent, if you say negative 3 times negative 3 over 2, you see you just get positive 9 over 2. And you still have the x, and now you're saying exponent minus 1. 1 can be written as 2 over 2. So that is just going to be negative 3 minus 2 is negative 5 over 2. And that is our answer. You can leave it as like this, okay, with a negative exponent, or rewrite it with a positive exponent. That is still fine. But at this point, it's acceptable to leave it like that. Moving on to the next question. Question 6.2.2 says, we have y over 3x and then it's equal to 1 plus x raised to the power of 2. And we need to determine the derivative of this function. Okay, so you see the problem, the main problem that we see here. The denominator of 3x. How do you get rid of that? You can simply just multiply both hand sides of this equation by 3x. So let's rewrite first. And multiply by 3x here and 3x here. Okay, what you do on one side, you must do on the other side. So y is equal to, and now we can just multiply. So let's just start with this part. And I should have written this as x plus 1 because, 1 plus x plus 1, still the same thing. So let's distribute that first. We still have the 3x in front, of course. So this is 3x. And then here, the x gets squared and becomes x squared. The last term gets squared and becomes a positive 1. First term times second term is x. And then you just double it. So multiply by 2, which is positive 2x. Okay, and this is what we have. And we can distribute in, and then we can just derive the function. Okay, so y equals, and this multiplies in to become 3x cubed. And then positive 6x squared and positive 3x. And now we're ready to find dy over dx. So that's going to be coefficient times exponent is 9. So we have 9x. Okay, and exponent minus 1 is 2. Then same thing here, coefficient times exponent is positive 12. And we have x minus 1 is 1. And then here we just have positive 3. And the x will fall away because exponent minus 1 is 0. And anything to the power of 0 is 1. And 3 times 1 just stays 3. And that is our answer. Okay. And moving on to the next question. Question 6.3 says, a function of h is given by h of x is equal to a times x squared plus b over x has a minimum value of 12 if x is equal to 2. Okay, so calculate the values of a and b. Another question which has shown up before So you see that with this question, they're just saying that this function has a minimum value of 12 if x is equal to 2. Okay, so it's not really going to be a parabola, but that doesn't really matter. It's going to be some sort of curve, and it's going to have a minimum value. Okay, so it probably has a weird shape, but it has a minimum value at some point, and they say it has a minimum value of 12. So if I was putting this on the Cartesian plane, not calling it a parabola, I'm just looking at the part of the graph that has a minimum value. But regardless of what it looks like, it has a local minimum, okay, really, at this point. So at this point, this is where x, they said if x is equal to 2, so x is 2, and it has a minimum value of what? It has a minimum value of 12, meaning its actual minimum value is 12, and that's your y value, okay? And we need to find the value of a and b for which this happens. Let's think about what happens at that minimum and what we can really do with this. So in a nutshell, what they've given us is this point 2 and 12. And they've given us this equation where a and b are missing. Two things are missing, meaning you need two equations to find it, or really two pieces of information to find it. But they've only given you 1 point. But it's a special point, okay? It's a turning point. That's why we have a minimum value. So a turning point can be used twice. You can use a turning point as a point, and you can also use it as a turning point. So here's what I mean by that. If you want to use this 2 and 12 as a point, you're just going to substitute it as if it's a regular point. So you're taking h of x, which looks like that, and in place of x, you're substituting 2, and in y, you substitute 12, meaning h of x, which is 12, we say 12 is equal to, and we say a, and there's x squared. So we'll say 2 all squared plus b over 2. Okay, and let's just see what we get with this. So you're going to get 12 equals, and this becomes 4. So 4a plus b over 2. We can just leave b on its own by getting rid of the 2. So you multiply both hand sides of this equation by 2. And so now we have, I'll just rewrite it on this side. You have this multiplies and just becomes b because it cancels with the 2. 2 times 4a becomes positive 8a is equal to 24. And then transpose the 8a. So b equals 24 minus 8a. And we have one equation now. Now, we've used it in the first way as a point, as a regular point. The second way we could use this point is as a turning point. Okay? Because it has a minimum value, this is what we can do. So let's look at what the graph does at this point. You see, all through here, we can actually speak about the gradient of this function. All through here, look at what this graph is doing. When you're reading it moving from left to right, this graph is decreasing, okay? And that means that it will have a negative gradient. If your gradient is negative, you have a decreasing function. When it's positive, you have an increasing function moving up, okay? So this graph is decreasing all through, and then it stops decreasing. Then it starts to increase. So what exactly happens at this point? What is the gradient at that point? This is a turning point. So at that point, the gradient is equal to 0. The gradient is no longer decreasing nor increasing. It's stationary. Okay, so that's what we're going to use. The fact that we know the gradient of this point. So the gradient of this function, h of x, we're going to find it. So we just have h of x. We'll have to rewrite it first in a way that x is not in the denominator so we can finally, derive that. So this is equal to, and we have a x squared plus b over x. And then we're just going to rewrite this so that x is in the numerator. So if you move it to the numerator, its exponent becomes negative. It had an exponent of 1, it's now negative 1. So now let's derive. So h prime of x, because we're trying to find the gradient, since we know the gradient of this function at one particular point. So h prime of x equals coefficient times exponent is 2ax. Exponent minus 1 is 1, so it just stays 1. And then coefficient times exponent is negative b, and you still have x here. And then exponent minus 1 will be negative 2. So this is the gradient of h. But we know that the gradient of h at the turning point, this is where x is equal to 2. We know that that gradient is equal to 0. So we're going to say, let's find the gradient at the point where x is equal to 2. So h prime of 2 is equal to, and in place of x, we're just going to substitute 2 all the way. So minus b, times 2 raised to the power of negative 2. And so now we're telling them that we actually know what this gradient is. We know what the gradient of h is where x is equal to 2. That gradient is equal to 0. So we'll say 0 is equal to, and we have here, this will multiply and become 4a. That, well, that's going to become a fraction. So you might as well just rewrite it as negative b, and then let's just move this base to the denominator so that its exponent becomes positive. So it's now 2 raised to the power of positive 2, which is of course 4. Okay, and you see that you can make b the subject here as well. This is just negative b over 4. You could take it over to the left to become positive b over 4 equals 4a. And then we can just get rid of this 4 by multiplying both hand sides of the equation by 4. And therefore b is equal to, that becomes 16a. Okay, so now you see that we have two equations with b as the subject. So we can say b is finally equal to b. Therefore, I'm just going to write the 16a first, just because, it's bigger than 8a, so it's going to be positive. It's equal to 24 minus 8a, and transpose that 8. So 16 plus 8, that's 24 as well. 24a is equal to 24. Divide both hand sides of the equation by 24. Therefore, a is finally equal to 1. And now that you have a, you can find b. So just take the value of a, substitute it into one of the equations of b. That one is easier. So b equals, okay, and we have 16 times 1, which is 16. And those are our answers. A is equal to 1, b is equal to 16, and that is it for question 6. Question 7 says, the graph of the cubic function of f. Okay, so they're already telling us it's a cubic function. The graph of the cubic function f has a turning point a, which is negative 1 and p, and b, okay, 2 and q. So they just don't tell us the y values. The function f has the following properties. Okay, it's best we just start drawing down at this point. So to draw this cubic function, just draw the x-axis first, so we can just mark where those points they're referring to are. So they told us that these are the turning points, right? At negative 1 and 2. So I'm just going to mark this so that I can find out, what we're really just doing here. So at negative 1, let's say this is negative 1 and this is 2 over here. So if we have turning points, then they first tell us that f prime of x is greater than 0 for where x is less than negative 1 and x is greater than 2. What does f prime of x mean? You see that from the previous question, you see f prime of x means the gradient, okay? So the gradient of this function is greater than 0, meaning positive, where x is less than negative 1 and x is greater than 2. So when the gradient is positive, it means that the function is increasing. When it's negative, it is decreasing. So it means that the function is increasing for values where x is less than negative 1. Here's negative 1. Values less than negative 1 are here on this side. So it means that the graph is increasing at this point, okay? So it's going to be going up, and then it reaches its turning point, of course, wherever that is. And then it also increases where x is greater than 2. So it moves up like that here, and it's also moving up at this point. So we just have to see where exactly that is. Okay, so greater than 0, it's moving up, and here it's also moving up. Yeah, you can already see it probably goes like that, and then up. That's why it's doing that. And then they also tell us that f prime of x is less than 0, where x is greater than negative 1, but less than 2. Greater than negative 1, but less than 2. That's all through here. This is where the graph has a negative gradient. Okay, it has negative gradients all through here. So it means that that is going to be decreasing. So you see how this is already piecing everything together. Here it's increasing, here it's increasing, here it's decreasing. Okay, all through from negative 1 all the way to 2. So yeah, in a nutshell, you see what our graph is going to look like. I just need to now find out if they tell us anything else about those turning points. So, okay, they say f of 2. This is one of the x values of the turning point. It is a value greater than 2. Okay, very good. That tells us something here. Meaning, I can't draw this turning point down here. Okay, because wherever that y-axis is, we need to ensure that the value of y here is a value greater than 2. So let's say this is 1, this is 2. It's a value greater than 2. So all that means is that this has a turning point that will be maybe somewhere here. I don't know where it is. It's just greater than 2. And that is 2, and the y value is, we don't know. Okay, it's just p. Did I say p? No, the q. Okay, so we'll just keep that as q. But it's just going to be above the x-axis. And then this one, well, they don't really say where it is, the other one. But we will write it down, but we still have to draw the graph. It just needs to go up, then down, okay, touch here, of course, and then back up again. So we can just remove these parts. And I know now that the graph is going to be going up like this at this point. And then here, it's going to look like this. So I'm just following the sketch that I just drew. And then at -1, it has a turning point. So make sure that you show that at -1. I think I need to move this closer. It has a turning point somewhere here. I don't know where that is exactly, but somewhere there. And then that goes like that, and then back down. So this really just shows you what the graph looks like. This is -1 and p. Okay, so this is what our graph looks like. And they already told us that it is increasing or has positive gradients where x is less than -1 but greater than 2. You see, if you go to -1, values less than -1, you see how this graph is increasing. You always read moving from left to right. Okay, so if you move up like that, that's increasing. Then here it's decreasing when it's between -1 and 2. And then here it's increasing where it is greater than 2. And yeah, that's everything. So yeah, they told us to draw a neat sketch of this graph, clearly label the points A and B on the sketch, and it's not necessary to show any x and y intercepts. So that is what our graph looks like. And that is it for this question. Just make sure you label this A and B. That's A, that's point B. Okay, moving on to the next question. Question 7.2 says, if f of x is equal to x cubed plus bx squared plus cx plus d, calculate the values of b and c. Okay, so they've given us the value of a, or really the coefficient of x cubed. And they want us to find b and c. Okay, that makes sense. You see, they want us to find b and c, but think about the only things that you have on this graph. The only thing you know for certain are the x values of your turning points. But here's the thing about a cubic function. If you derive this cubic function, you will get a parabola, specifically a concave parabola, seeing that the value of a here, okay, the value of the coefficient of x cubed is a positive value. So you'll have a concave parabola. And that concave parabola, it will have x-intercept specifically at -1, okay, that x value of the turning point, that first one, and at 2, the second x value of the turning point. That's what's going to happen. So we can use that, and let me just leave this down here just so that you can see what happens. If we know that these are the x-intercepts of this parabola, the derivative of f, okay, that's f prime, then what we can do is just derive this function, see that it will include b and c. When you derive it, only d will fall away. And then we can finally find the value of b and c by using these as the only 2 points we have on this graph. So let's derive this. So to find the parabola's equation, so f prime of x is equal to coefficient times exponent. We have 3x to the power of 3 minus 1 is 2. And then here, coefficient times exponent, 2bx. Exponent minus 1 is 1, and we don't have to rewrite that. And then plus c. And the x will fall away because exponent of 1 minus 1 is 0. And of course, that becomes 1. And d is gone. Okay, d is a constant. Okay, it's the only one without any x. So this is what we have. And now that we have derived this function, we can find the equation of it because it's a parabola. Okay, it's a parabola, and you know what the coefficient of x squared is. So, and you also know the x-intercepts of the parabola. So you can simply just use the x-intercept form of the parabola. So this is f prime of x is equal to, the coefficient of x squared is 3. And then you're going to say x minus the first x intercept value, okay, which is, we have -1 and then 2. So minus -1, which just becomes a +1, and then x minus 2. Okay, so x minus -1, x minus 2. And this is what we have. And all we have to do is just distribute, simplify, and we will find out what b and c are. Okay, so f prime of x is finally equal to 3. And then multiply. This is going to be x squared. And then if you multiply, that's -2x. And you multiply that, that's positive x. So they become -x. And then times -2. Distribute the 3 in. F prime of x is equal to, and we have 3x squared minus 3x and then minus 6. So this is our equation. And we're really saying, you see, I don't know why I said, I forgot the prime, f prime of x. We're saying that this equation is exactly the same as this equation. So because of that, what this means is just match their coefficients, okay? X squared has a coefficient of 3. That's fine. Now the coefficient of x here is -3, but here it was 2b. So that would conclude that 2b is actually equal to -3 because their coefficients must be the same. They are the same equation. And so here that would mean that c is equal to -6. Okay, so and c equals -6. And we just need to solve for b. So you can divide both hand sides of the equation by 2. Therefore, b equals -3/2 and c equals -6. Okay, and that is our answer. And that is it for question 7. Question 8 says, during an experiment, the temperature T in degrees Celsius varies with time T in hours. Okay, according to the formula, and this is the equation. Okay, they give us the formula for T of T. So this is the temperature at different times, and they specifically say that T is an element of 0 to 10. We know that this small t is in hours. So this experiment is conducted within 0 to 10 hours. Okay, so the first question says, determine an expression for the rate of change of temperature with time. So with respect to time. So they're just asking for the rate of change. So if this is the temperature with respect to time, what would be the rate of change, the formula for this with respect to time as well? The gradient of this function, okay? So the derivative of this function. And so to find this is t of t is equal to, I just rewrite this first. I'm rewriting it just to see if there's anything we have to change. Everything seems fine, okay? There's no t in the denominator or anything like that. Everything's okay. So we need to find the gradient of this function or the derivative, and that will be the rate of change. So we'll say t prime of t is equal to, when you derive a constant, it just becomes 0 because it's just a flat horizontal line, really. The gradient of this is 0, okay? And we have 4t. So when you derive this, and you can already see its gradient is 4, okay? So coefficient times exponent, exponent minus 1, that just becomes 0. Anything to the power of 0 is 1. And here, coefficient times exponent, -1/2 times 2. You see those 2's will cancel diagonally, and you have -1. So this is negative, and we have t, and then exponent minus 1 is 1. Okay, so this is our answer, and yeah, that is it for this question. So this is a change in temperature with respect to time. Of course, here, the time was from 0 to 10 hours. Moving on to the next question. And then 8.2 says, during which time interval was the temperature decreasing? Okay, so when we're trying to find out what something is doing, okay, whether it's increasing or decreasing, remember what we focus on from the previous question. You focus on the gradient, which we just found. Okay, we found the change in temperature with respect to time. So if the gradient is positive, this is where it is increasing, okay, because this will be an increasing function to be moving up. And then if the gradient is negative, it is decreasing. So we already know what the gradient of this function is. It is 4 minus t. So where the gradient is negative, meaning this needs to be a value that is less than 0. And we just need to solve for this inequality. Okay, so remember at that point where the gradient or the change in temperature is equal to 0, that's when that change happens, okay? It moves from decreasing to increasing or increasing to decreasing, okay? So when it is decreasing is when it's less than 0. And then we can solve for this inequality. It's a linear inequality, so very simple to solve. You can decide to take this over, and then that would solve for it. Or you could take 4 over and then divide both hand sides by a negative value. Then you need to remember what happens with the sign. So if we left this here, negative t, it's still less than, and we're taking the 4 over, it becomes negative 4. Then we could multiply or divide by negative 1. I'll just multiply, so both sides by negative 1. And so this makes this positive t, and the sign will change to greater than, okay, 4. So t is greater than 4. But remember that t, okay, goes from 0 to 10. So we need to also remember that parameter they gave us. So let's just tell them, but we know that t is an element of 0 all the way to 10. So think about the values that are greater than 4 that are within this interval. So greater than 0, greater or equal to 0, but less than or equal to 10. So that would be, since we're saying that t is greater than 4, we're starting here and we're saying values greater than 4, so all through here. Okay, so you see that our answer should include numbers like that are greater than 4, so 5 and 6 and everything greater than 4 really, because they didn't really say that we can only use integer values here. So to specify that, you need to tell them that t is values that are going from 4 to 10, but just greater than 4, but less than or equal to 10. So I'll say greater than 4, but less than or equal to 10. And that will be my answer. You could also write it like this in intervals. So it will be t is an element of, and we're saying it's going from 4 to 10. But we're saying greater than 4, not equal to 4. So I'll use a round bracket there, and then equal to 10, so a square bracket there. And that's what it would look like. So either like this or like this is fine. And that is our answer. Okay, and that is it for question 8. Okay, so that is the last question, and that wraps it up for this paper. I hope you guys enjoyed it. Please leave comments if you have specific questions about it, and I hope to see you guys in paper 2.